Yeah, I think let's start and then let's others can join later. So, dear students, it is an absolute pleasure to welcome you all to the first lecture on grade 11 chemistry with Edu Infinite. I will start with a quick background. My name is Brotin and I'm a co-founder of Edu Infinite. I did my schooling from St. Xavier's Calcutta, then my engineering in electronics from Jadavpur, and then did my MBA from IIM Calcutta. So I have been a banker for the last 20 years and been working overseas. Currently, I'm based in Singapore and work for Bank of America. So we started Edu Infinite in Singapore, which is a specialized education center here. We offer classes to students from the top international schools in Singapore. We started our India operations and launched our first center in Kolkata. We have partnered with Yukti, which is an IIT alumni body with about 2 decades of experience in training students for engineering and medical entrance examinations. Uh, Currently, Yukti has 25 plus centers mostly across Western India. And over the years, numerous successful students, including rank holders in IIT number one, ISC, CBSE number one, have taken coaching at the Yukti classes. So we will be providing comprehensive coaching for engineering and medical entrance exams, along with focus on the board level exams as well. So currently, given the COVID-19 situation, we are offering live interactive classes over the web by eminent faculty members on a number of subjects, including physics, chemistry, maths, biology, English, and accountancy. So for our chemistry classes, we are fortunate to have with us our dear sir, Sri Shubhabrata De. Sir has been teaching students for the last 30 years, both at board and competitive level exams. So let me just spend a couple of minutes on how we plan to conduct the classes. So we will be offering 2 classes for grade 11. One class would be covering both the board and competitive exams like JEE and NEET. The other class would only focus on the board level exams. The classes would be interactive and the students will be able to clarify their doubts, concerns. We will be having regular assessments to make sure the students are able to grasp the concepts taught in class. And again, we will be having regular assignment sheets which will be provided to students. The study material, access to online testing and practice platform will only be provided to students who would be joining the competitive class for JEE and NEET. Again, from a monitoring perspective, we would set up individual WhatsApp groups for each student. You will be able to post all your queries on that chat and your queries will get promptly addressed. You can also reach us via email and phone. Our center manager, Mrs. Meena Shur, will be monitoring all these chats. And in case any students miss any class, we can get access to some of the recorded sessions as well. And finally, please note that our physical center is located on SP Mukherjee Road near Kalighat Metro Station, just opposite Tollygunge Police Station. However, we will continue with online classes even when we start the physical classes at some point. With this, I'll stop here and pass this to Sir. Happy learning. Thank you.
So, good afternoon, all my dear students. I'm Mr. Shubhabrata De. Brotin sir has already explained everything about me, about the experience and everything. Everything is depending upon you, how you are enjoying the class. Being the first class, so I will do some basic thing, that the first chapter, basic concepts of chemistry. Those who are from the ISC batch, they have the knowledge. For other boards, CBSE and West Bengal board, they may have some idea about some basic laws depending on which the entire chemical calculation based on numericals are there in this chapter. This is a very important chapter. Questions may be from different angles, including the discovery of the particular law and everything in the table form, table matching form. So questions will be in different ways. we have to prepare the entire chapter. One thing is the preparation, the thorough preparation for the board exam, and the other, the memory based questions and everything for which you have to develop yourself. So being the first class, I will start the chapter along with some basic laws. Those who are in the competitive level, definitely maybe plus 12, or they are in their plus 12 level, or may appear for NEET or JEE advanced or other exams which are still remaining to be held in the month of September. So for them also, what I suggest, just follow the class, and after that I will do some basic numericals, the tricks and the method by which, because for the particularly for the competitive exam in MCQ level, one single option correct, time is very short. If you do the right, you will get full marks. If you're wrong, 25 marks will be deducted. So if it is a 4 marks question, if you do correct, you will get full 4 marks. If it is wrong, for the wrong answer, deduction, and 1 mark also from the score what you have gathered, okay, with the right answer. So be careful about the MCQ part. That I will do that part later on. Let me start with some basic concepts. This chapter mainly comprising of 5 basic laws: law of conservation of mass, law of constant proportion or definite law of constant composition or definite proportion, law of multiple proportion, law of reciprocal proportion, and Gay-Lussac's law of gaseous volume. So let us start with the first law, law of conservation of mass. You have all the idea about the law of conservation of mass, that is, matter is indestructible, it can neither be created nor be destroyed. The total mass of it during any reaction, before and after the reaction, remains constant. That is a basic law. Question will not be in any way that state the law of conservation of mass in this class 11, 12 level, but the law of conservation of mass is not fully justified. You may write down the question for the board exam. Law of conservation of mass is not fully justified. Before continuing further, if you have any query during my class, just one after another, otherwise it will make a chaos. Sound problem may develop. Just one after another, you just unmute and may ask the question, or if you have any query regarding the topic. Now, law of conservation of mass, already have mentioned. The law of conservation of mass is not fully justified. You may write down the question. You have to ask for justification or explanation. In chemical reactions, what we do in our practical lab, the mass of the reactants and the products may be maximum 500 gram, not beyond that, because the apparatus in which we do the practical experiments, depending on that, maximum 500 gram of reactants may be used. So this, when reaction takes place, the reaction may be either exothermic or endothermic. The question is, where from this energy transformation taking place? It was been explained by Einstein by his famous theory of relativity, and he showed by means of an equation, E is equal to mc square, where E is the energy produced, M is the change in the mass of the reactant, and C the velocity of light. So following this equation, we can calculate the change of mass into energy. You see, if we calculate the change in mass, it will be E by C square. Now, in general chemical reactions, the energy thus produced is so small compared to the square of the velocity of light. So dividing this value becoming very, very small. Say, if we take initial mass of the reactant as 500 gram, change in mass into energy will be hardly 0.0001 gram compared to the initial mass, that is 500 gram of the reactant. The change in mass is so small. It is becoming 4.99999, something like that. So whatever the balance you are using for measuring the reactants and products, this will not be properly measured in the chemical balance. This will show approximately 5, sorry, this will be approximately
Hi, I think we just had a temporary disconnection with Sir. Just give us a minute and we will be connecting back. And while we are waiting for Sir, I've seen few more students join as well. So just as a quick background, uh, today's class we're doing is a trial class covering both joint the competitive exams as well as the board level exams. However, going forward, what will happen is we will be offering two classes. One which will only focus on the board level exams. The other class would be covering both the board as well as the competitive exams. So again, all these classes should be small batch sizes and should be quite interactive. So students should be feel free to clarify all your doubts, your concerns. So you can unmute yourself, raise any question with Sir. If even after the class, if you have any queries, you would have access to WhatsApp, email. You can send us those details. So we would be having regular assessments to make sure that whatever is happening in class, you are able to grasp the concepts. And again, regular assignment sheets will also be provided to the students. For students who would be registering for the competitive level courses, they would also have, in addition, study material, online testing platform, online practice platform, and that would give you ample questions through which you can sort of make sure you have access to all the different questions over the years and get yourself ready for the board as well as the competitive level exams. Uh, Again, as I mentioned, we have a partnership with Yukti, which is a group of ex-IIT alumni body with over 2 decades of experience in training students for both engineering and medical exams. So whatever exams you're giving, you would be able to see your ranks in a group of a wider group of students, about 1,000 across the country. So that will give you a good understanding how you're comparing how students from Mumbai, from Gujarat and other centers are doing, which is very useful, especially for the board level, sorry, for the engineering level and NEET level exams. And finally, we will be creating an individual WhatsApp group for each student. You will be able to post all your queries on the chat and which should get promptly addressed. Mrs. Meena Shur, our center manager, would be monitoring all these chats. Okay, just 1 second. Let me just get Sir back on the line. Yeah, I think the connectivity is back. Sir, I think you're on mute.
Is it okay now?
Yes.
Okay.
So
I'm
again, so
sorry students, some network problem developed. Okay, so what I discussed with respect to the nuclear reactions, huge amount of energy is produced. So in that case, E becomes so high, dividing by the square of the velocity of light, we are getting an acceptable change in mass. So considering both chemical and nuclear reactions, we can finally conclude that whether a chemical reaction or a nuclear reaction, mass is getting converted to energy and vice versa. So, considering this fact, we can say that law of conservation of mass is not fully justified. Then what should be the actual law? It's a combined law of mass and energy together, which states that the total mass and energy of any reaction, whether chemical or nuclear, is always equal before and after the reaction. So, this is the modification of the law of conservation of mass. I think it is clear to you now. Law of conservation of mass is not fully justified on the basis of mass and energy conversion, and on the basis of Einstein's equation E is equal to mc squared. Mass is getting converted to energy during any reaction. For chemical reaction, compared to the mass of the reactant, the change in mass is so small, we are not considering it. So, for our numericals, if it is not a nuclear reaction for competitive exam or for board exam, if it is not a nuclear reaction or huge amount of energy is not being produced, we should have to show that the total mass before and after the reaction remains constant. Now, let us consider a simple experiment as done by Landau. He has taken a H-shaped tube, though it is applicable for chemical reactions only. We have to explain on the basis of these the justification of the law of conservation of mass on the basis of Landau's experiment. Landau took one H-shaped glass tube, one containing initial solution and other containing AgNO3 solution. This is the spout. Initially, these are open. Take initial solution onto this tube and AgNO3 solution onto this tube. Then plug this top and then tilt. Okay, before tilting, you just take the mass of the entire system if it is equal to W1 before the mixing, and now tilt the entire solution so that this and this mix up with each other, and you will see initially both the solutions are clear solutions, but after mixing you will get white precipitate of AgCl along with the formation of NaNO3. So formation of this white AgCl indicating that the chemical reaction is taking place. Now, after mixing, when you have got the white precipitate, again you take the mass of the entire system. As I told you, if this one becoming W1 gram initially, after mixing and after having the reaction, if it is equal to W2, you will see that W1 is equal to W2. This is the experimental verification of the law of conservation of mass as done by Landau. Okay, so take one example or one numericals in the form of MCQ. In the form of MCQ, you may write down this one. 10 gram of marble, means calcium carbonate pure, on heating leaves behind a solid residue weighing weighing 5.6 gram. Volume of CO2 gas released at NTP or STP is how much? Four options are given. Option A is 2.24 liter. Option B is 4.48 liter. Option C is 1.12 liter. And option D is 0.56 liter. Now, this is a chemical reaction based calculation. Again, I am repeating the numerical. 10 gram of calcium carbonate on heating leaves behind a solid residue weighing 5.6 gram. Volume of CO2 gas released at NTP is how much? Four options are given. You have to find out the correct option. Now, for doing this numerically a very short form, what to do? Calcium carbonate on heating, always chemical reaction based calculation, you have to balance the chemical equation first, giving calcium oxide as a residue and carbon dioxide gas. Now, calculate the molecular mass of calcium carbonate, which will be 100 gram because calcium is 40, carbon is 12,
Sir,
the oxygen 16 to
sir,
3.
is the answer A?
Yeah, exactly. Answer is option A. So 100 gram, this is giving 56 gram, and this one, this is 44 gram, but don't do this one because weight versus volume. 44 gram of carbon dioxide at NTP means 22.4 liter at NTP. So we need this one versus this one first. We have to check one thing. I will just change the problem in a little bit different way. When this is 100 gram, residue is 56 gram, and volume of CO2 produced is 22.4 liter. Given question, as per given question, calcium carbonate is 10 gram, residue is 5.6 gram, and this should be 2.24 liter at NTP. So you don't have to do a big calculation because in competitive exam, you are not allowed any computer or any system, electronic media or system to calculate the numerical, the calculation part. So in a simple manner, 10 gram, 5.6 gram, 2.24 liter. I think is it clear to you? I think is it clear to you?
Yes, sir.
Okay, now I am changing this problem. I am changing this problem in a different manner. Okay, write it down. Write down 10 gram of a piece of marble. 10 gram of a piece of marble was put into excess of dilute HCl solution. 10 gram of a piece of marble was put into excess of dilute HCl solution when 1120 cc of CO2 gas at NTP is produced. When 1120 cc of CO2 gas at NTP is produced. Okay? Question is the percentage purity of calcium carbonate, in the given sample is option A 25%, option B 50%, option C 75%, and option D, none of these. None of this. Okay, so the same problem, instead of direct heating, we are treating marble. Here the reaction should be calcium carbonate versus HCl dilute to give calcium chloride plus CO2 plus water. We don't need this one. We don't need this one. We have to correlate between this and this. As per the previous problem, 100 gram of this one calcium carbonate is giving 44 gram or 22.4 liter of CO2 at NTP. So 22.4 liter means 22400 cc. 22400 cc. Given volume of CO2 is 1120. 1120. So see, simple multiple of this one is this. So 1120. So it should be how much? Anybody please? So you have to do the calculation on the basis of carbon dioxide produced. 22400 cc of CO2 is produced from 100 gram of pure calcium carbonate. Therefore, 1120 of CO2 is produced from, by calculation, this is this
5 gram.
This multiplied by 20 becoming this. So this must be divided by 20. So this is becoming 5 gram. So out of the given mass of marble, it was given 10 gram. Pure calcium carbonate is 5 gram. Therefore, percentage purity of calcium carbonate is equal to how much? 5 gram out of 10 gram sample into 100, becoming 50% is the answer. So same type of numerical in a different manner. Is it okay? Is it okay?
Yes, sir.
Okay. Any query from anybody, please? Be free to discuss. No hurry, no hesitation, please. Silent means it is okay to everyone. Is it so? Okay.
Yes,
Next, come to the another problem. Okay, I will come later on about the MCQ another type. Second law is the law of constant composition or law of definite proportion. Law of definite proportion or constant composition. Okay, so this law was given by Joseph Proust. So sometimes the name of the scientist may ask in your question for MCQ part. In 1799, Joseph Proust gave this law of definite proportion or constant composition. Very simple law. A pure chemical compound always consists of the same elements combined together in a fixed or definite proportion by weight. Again, I am repeating, a pure chemical compound always consists of the same elements combined together in a fixed or definite proportion by weight. Let us explain what does the law mean. Let us consider water, which is a definite compound. A pure chemical compound is water, which is consists of two definite elements, hydrogen and oxygen, in definite weight ratio, in a definite or constant weight ratio. Hydrogen is to oxygen is equal to 1:8, and volume ratio H is to O is equal to 2:1. So we may consider the weight ratio as well as volume ratio. So it is clear that always a pure chemical compound is composed of certain definite elements in which those definite elements are combining in a definite weight ratio, giving that particular compound. Again, question will not be asked in your board level, state the law of definite proportion. But important question is converse of the law of definite proportion. You write down the question. Converse of the law of definite proportion is not always true. Converse of the law of definite proportion is not always true. Okay? Dash, explain. So this is an important question. Before proceeding further, think the law in a very simple manner, that always a definite pure compound is composed of definite elements in their definite weight ratio. Okay? But in writing the law, you must have to follow the statement as given by the respective scientist. Now, what should be the converse of the law? Before I asking the question, what should be the converse of the law? Let me say something about what does it mean by converse or corollary. In class 9-10 level, you have done two consecutive theorems in geometry. The line joining the midpoints of any two sides of a triangle is parallel to the third side and is half of the third side. You have done this theorem in class 9-10 level. The line joining the midpoint of any two sides of a triangle is parallel to the third side and half of the third side. If you consider this is the theorem, the inverse, the converse of the law, or the converse of the theorem or the corollary will be the line joining the line drawing from the midpoint of any side of a triangle parallel to the second side will bisect the third side. Line from the midpoint of any side of a triangle parallel to the second side will bisect the third side. So these two laws are said to be converse to each other. Now anyone please tell me what should be the converse of the law of definite proportion? What should be the converse of the law of definite proportion? Anybody please, just you arrange. Try please. A pure chemical, the law states that a pure chemical compound always consists of same elements combined together in a fixed or definite proportion by weight. This is the actual law given by Proust. Converse of the law will be, you may write down, converse of the law will be definite elements combining in definite ratio, combining in definite weight ratio will always produce a definite compound. Definite elements combining in definite weight ratio will always produce a definite compound. Now let us verify. As I have told you, we have considered water is a definite compound composed of hydrogen and oxygen, two definite elements. In the weight ratio, hydrogen is to oxygen, 1:8. That means converse of the law will be two definite elements, namely hydrogen and oxygen, combining in the weight ratio 1:8, always will produce a single definite compound, that is water. Two definite elements, namely hydrogen and oxygen, combining in definite weight ratio 1:8, will always give rise to the formation of the definite compound water. In case of water, it is okay, but everywhere it is not so. Let us verify. We are considering two definite elements, carbon and hydrogen, in which carbon and hydrogen, two definite elements, are combining with the weight ratio of 12:1. We are taking two definite elements, carbon and hydrogen, and we are reacting them in the definite weight ratio. Carbon is to hydrogen is equal to 12:1. Now see what is happening. These two elements combining with each other in this definite ratio 12:1 may give rise to the formation of C2H2 acetylene. Okay, check. In acetylene, carbon is to hydrogen is equal to 12 into 2 means 24 is to 1 into 2 means 2, that is 12:1. 12:1. So it is matching this ratio. Again, consider another compound, benzene, formula C6H6, in which the weight ratio carbon is to hydrogen is equal to 6 into 12 means 72:6, becoming 12:1. So see, the two definite elements, carbon and hydrogen, combining with each other in the definite ratio 12:1 may give rise to different compounds, acetylene and benzene. What is the relation between these two? Anybody please? What is the relation between these two? Any idea? These are called
both are
isomer.
alkynes.
These are called isomer. So to say, in case of isomers, converse of the law of definite proportion is not taking place properly. Okay, in case of isomer, a converse of the law of definite proportion is not justified. This is one case. If you consider another type of compounds, say one is C2H5OH. This is called ethanol or ethyl alcohol, ethanol and alcohol, and another compound CH3OCH3, common name is dimethyl ether, common name is dimethyl ether, and IUPAC name is methoxymethane, methoxymethane, whatever it is. One is an alcohol, other is an ether. These are having the same molecular formula with same definite elements, combining the same definite weight ratio, but giving rise to the formation of two entirely different compounds. Anybody please? What are these two type of elements called? Okay, I'm sorry. This is called polymers. This is called polymers because C2H2 can be written as CH whole 2 and C6H6 can be written as CH whole 6. So same empirical formula, only this factor are differing 2 and 6. These are called polymers and these are called isomers. These are called isomers. So to say, converse of the law of definite proportion is not applicable in case of isomers and polymers. Is it okay? Is it okay, please?
Yes, sir.
Okay. Another thing, limitation of this law. Limitations of the law of multiple, definite proportion or constant composition having some limitations. One is the important one. Let us consider simple formula. Water, simple example. Now you are taking hydrogen and oxygen, two definite elements to form water. In case of one, you are taking protium isotope and 8 oxygen 16 isotope. In case of another type, you are taking 1H1 protium, the same hydrogen isotope, but you are taking 8 oxygen 17 isotope of oxygen. Then the weight ratio will differ, though the compound we are saying as water, H2O, but having different isotopes of oxygen, mass or weight ratio of hydrogen or oxygen in the product will differ. So limitation is considering the definite elements during the formation of the definite compound, same isotope to be considered. Okay, next comes to the law of, okay, what problem with respect to this one? Okay, you write down the mass of copper oxide, the mass of copper oxide, the mass of copper oxide obtained by heating 2.16 gram of copper, obtained by heating 2.16 gram of copper with nitric acid and subsequent ignition was found to be 2.7 gram, This is the first experiment in which 2.16 gram of metallic copper on heating with concentrated HNO3 followed by ignition is producing 2.7 gram of copper oxide. In another experiment, 1.15 gram of copper oxide. In another experiment, 1.15 gram of copper oxide on reduction produced 0.92 gram of copper. 0.92 gram of copper. Show that the data illustrates the law of constant composition. Show that the data illustrates the law of constant composition or definite proportion. Now comes to the first experiment, where mass of copper is 2.16 gram. So mass of copper is 2.16 gram. Mass of oxygen combined is 2.7 minus 2.16 gram. Okay, minus 2.16 gram, which is becoming 0.54 gram. Okay, therefore copper is to oxygen is equal to 2.16 is to 0.54. Okay, this is one experiment. Now, what should be done? This divided by this to make this one 1, or this divided by 2.6 to make this one 1. Always keep in mind the least one to be converted to 1. So divide both this by the least one, 0.54, so that this is becoming 1 and this is becoming 2.16 by 0.54. find this value. Another is, in the second experiment, mass of copper is 0.92 and mass of oxygen combined is equal to 1.15 minus 0.92. Find this one and then find the ratio copper is to oxygen. In both the cases, check whether the two masses are, two ratios are becoming same or not. So in this case, weight ratio copper is to oxygen is equal to 0.92 is to 0.23 is equal to 0.92 by 0.23 is to 1. Check whether these two ratios are becoming same or not. And if it is same, then we can say that in both the cases, the weight ratio of copper and oxygen in copper oxide remains the same. So it is just to illustrate, it is illustrating the law of definite proportion of constant composition. Is it okay? Is it okay?
Yes, sir.
Yes, sir.
Okay. So try to do the numerical in a very simplified manner so that there is no chance of having any error. Next, the third law. Third law is law of multiple proportion. Law of multiple proportion. Before explaining the law or before saying the law, let me discuss some example. Simple example always. Carbon plus oxygen. Two definite elements combining in different weight ratio, producing two compounds. One is carbon monoxide, other is carbon dioxide. Again, carbon and oxygen, these two elements combining in different weight ratio, giving rise to the formation of two different compounds. One is carbon monoxide, other is carbon dioxide. Now here, in carbon monoxide, carbon is to oxygen, weight ratio is 12 is to 16. And in carbon dioxide, carbon is to oxygen is equal to 12 is to 32. Okay? Out of the two elements, make any one constant. Here, see the parts by weight of carbon in both the cases remains the same, 12. This is constant. So oxygen in the first case versus oxygen in the second case, weight ratio becoming 16 is to 32 is equal to 1 is to 2, which is a simple ratio of small whole numbers. Again, carbon and oxygen, two definite elements combining in different weight ratio, giving two different compounds, carbon monoxide and carbon dioxide, in which carbon is to oxygen, weight ratio in carbon monoxide is 12 is to 16, while that in carbon dioxide is 12 is to 32. After finding this, keep the mass of any one of the two elements fixed. Here, we have made carbon 12 constant. So, what is the weight ratio of oxygen in the two different compounds? 16 is to 32 is equal to 1 is to 2, which is a simple whole number ratio. Now comes to the law following this example. If two elements combine with each other to form minimum two or more different compounds. If two elements combining with each other form two or more different compounds, then the weights of one of the element, we are considering weights of oxygen. The weights of one of the element, one is 16 here, one is 32 here. The weights of one of the elements which combine with a fixed weight of the other element, here the fixed weight is of carbon. So weight weights of one of the elements, 16 and 32, combining with the fixed weight of the other, these weights bear a simple ratio of small whole numbers by weight. Okay, bear a simple whole number ratio by weight. For board students, I recommend you all, if the question is state the law of multiple proportion and explain by a suitable example, then follow this example what I am going to write. Nitrogen and oxygen combines with each other to form different oxides. Nitrogen and oxygen combining with each other forms 5 different oxides. This one is nitrous oxide. Nitrous oxide. Then a nitric oxide. Nitric oxide NO. Then dinitrogen trioxide. This is a dinitrogen trioxide. Dinitrogen trioxide. Then NO2, nitrogen dioxide. Nitrogen dioxide. And finally, N2O5, nitrogen pentoxide. Nitrogen pentoxide. So, nitrogen and oxygen, two elements combining with each other to form 5 different oxides. Now, in nitrous oxide, nitrogen is to oxygen, weight ratio, atomic number of nitrogen is 14. So 28 is to 16. 28 is to 16. In nitric oxide, nitrogen is to oxygen is equal to 14 is to 16, means 28 is to 32. What we are doing? We are fixing the mass of nitrogen everywhere as 28. 14 is to 16 means 28 is to 32. In a dinitrogen trioxide, nitrogen is to oxygen is equal to 28 is to 48. In nitrogen dioxide, nitrogen is to oxygen is equal to 14 is to 32, means 28 is to 64. And the last one, nitrogen pentoxide. Nitrogen pentoxide, nitrogen is to oxygen is equal to 28 is to 80. Okay? So, in 5 different oxides of nitrogen, keeping the mass of nitrogen everywhere fixed as 28, everywhere 28, then the ratio of the weights of oxygen in the 5 different compounds will be 16 is to 32 is to 48 is to 64 is to 80 is equal to 1 is to 2 is to 3 is to 4 is to 5, which is a simple whole number ratio, which is a simple whole number ratio. Thus, the validity of the law. Thus, the validity of the law. Is it clear?
Yes, sir.
Okay. Now, some interesting question. Some interesting question. Okay. one. The oxide of nitrogen, containing 26% by weight of nitrogen, 26% by weight of nitrogen is option N2O, N2O3, N2O5. Hurry up. Tell me the answer. The oxide of nitrogen containing 26% by weight of nitrogen is optometry is a medical term. Okay. Optometry is a medical term. But I say something different called archometry. Arch means eye. Archometry. Metry means measurement. In some numericals for MCQ, you have to measure the numerical before doing anything by your eyes. Okay, so you have to measure by your brain along with your eyes. See this one, nothing to do first. If any student do calculation of percent of nitrogen here, answer is not 26%. Here, may or may not 26%. Here, may or may not 26%. Finally, this one. So, if A, B, C goes wrong, then finally he or she has to calculate the fourth one. That causes huge loss of time. But what about the archometry? Just apply your brain. Nitrogen is 14, oxygen is 16. Nearly 48, 52% or something like that, 49, 51%, may not be 26%. Here, nitrogen is 28, oxygen is 16. So nitrogen becoming more than that of oxygen, but here the reverse. Nitrogen is less than that of oxygen. So this fails and this fails. Come to this one. This is 28 is to 48. Again, this is not equal to 26%. So this goes wrong, this goes wrong, this goes wrong. Just by your brain. Okay, brain were the points. What I called it as apply your brain. So there are some tricks. Don't go calculation for this one, and this one. Right? Finally, this one do calculate, you will get the answer. Check. Here nitrogen is 28, total mass is 28 plus 80, that into 100, and this will be 26%. Is it okay?
Yes, sir.
Fine. So, for doing MCQ, before doing that, you have to go through the theory portion first. Must have to follow the worked out examples from any good textbook. Then go for the MCQ and exercises. Okay? Comes to the fourth law of reciprocal proportions. Out of the 5 laws, as I have told you, this one is the most complicated one. That's why very common question for board exam. State the law of reciprocal proportion and explain with an example. Law of reciprocal proportion. Law of reciprocal proportion. This law was given by Richard. Okay. was given by Risher. Again, before explaining the law or defining the law, let us have a very suitable example. Carbon, hydrogen, oxygen. Three elements. Carbon and hydrogen reacting with each other to form methane. Hydrogen and oxygen combining with each other to form the most common compound, water. So hydrogen is the common one. In CH4, weight ratio, hydrogen is to carbon is equal to 4:12. And in water, hydrogen is to oxygen is equal to 2:16 is equal to 1:, this one is 1:3, and this one is 1:8. The law states that when two different elements combine separately with a third element to form two different compounds. Again, when two elements combine separately with a third element to form two different compounds, then the weight ratio of these two elements, namely carbon and oxygen, combining with a fixed weight of the third element, will be maintained in the compounds formed by these two elements. Means to say, when these two elements will combine with each other, they will maintain this weight ratio 3:8, or a simple multiple of this ratio. The ratio in which two elements combine separately. The ratio in which two elements combine separately with a fixed weight. Here, fixed weight of hydrogen is 1, with a fixed weight of the third element. This weight ratio is either the same or a simple multiple when these two elements will combine to form any compound. Again, I am repeating, the ratio in which two elements, the ratio, that means 3:8 here, two elements combine separately with a fixed weight of the third element. This weight ratio is either the same or a simple multiple of this ratio when these two elements combine with each other to form any compound. So let us verify the law. We came to know that one part of hydrogen combines with 8 parts by weight of oxygen to form water. Again, one part of hydrogen combining with 3 parts by weight of carbon to form methane. Now, when carbon and oxygen combine with each other to form two different compounds, one is CO2, other is CO, then check whether carbon and oxygen, these two elements, are maintaining this weight ratio 3:8 or not. Already we have got that here carbon is to oxygen is 12:32, means 3:8, so maintaining the same ratio as stated. And in carbon monoxide, carbon is to oxygen is equal to 12:16 is equal to 3:2 is equal to 6:8. See, this 8 is same to this one, but this 6 is a multiple of 3. Multiple of 3. So either the same ratio or the multiple of the same ratio. That's the law. The ratio in which two elements combine separately. The ratio in which two elements combine separately with a fixed weight of the third element is either the same or is a simple multiple, is either the same in carbon dioxide or a simple multiple of the same ratio when they combine with each other to form any compound. Is it okay?
Yes, sir.
Everyone please. Everyone please.
Yes, sir.
How to find out? Sometimes law will not be mentioned. After giving the numericals, question will be which law of chemical combination is supported by the given data. Prove it. So how can we find out the given data follows which law? If you see that every time the data is saying about a definite compound, a single definite compound, it is definitely law of definite proportion. If in the numerical, if it is seen that the data is related to two definite elements but giving different compounds like carbon monoxide, carbon dioxide, like 5 oxides of nitrogen, like cuprous oxide, cupric oxide, mercurous oxide, mercuric oxide, sulfur dioxide, sulfur trioxide, blah blah blah. Then elements are same but in a different weight ratio giving different compounds. It is multiple proportion. In case of reciprocal proportion, 3 elements will be given: A, B, C. A versus B, B versus C, C versus A. Okay? So we have to find out which law is stating the given data. Last law is Gay-Lussac's law of gaseous volume. The most easy one you have done in your plus 10 standard. Gay-Lussac's law of gaseous volume. Under similar conditions of temperature and pressure, whenever gases combine, they do so in volumes which bear simple whole number ratio with each other and also with the gaseous product. Means to say, very simple example, hydrogen plus chlorine, both are in the gaseous state, reacting with each other, giving hydrogen chloride a gas at same temperature and pressure. That is the condition, same temperature and pressure, we are getting that 1 volume hydrogen reacting with 1 volume chlorine to form 2 volumes of HCl. Hence the volume ratio, hydrogen is to chlorine is to HCl. Volume ratio is 1:2, which is a simple ratio of small whole numbers, or simple whole number ratio. So that is the simple law. Now write down one question step by step. Those who join later, just write down. First question is, law of conservation of mass is not fully justified. Explain. Second question, converse of the law of definite proportion. Converse of the law of definite proportion is not always true. Third question, what are the limitations of the law of multiple proportions? What are the limitations of the law of multiple proportions? A very simple answer. During considering the definite elements, same isotope to be considered, otherwise ratio will vary. What are the limitations of the law of multiple proportion? And last question, how does Gay-Lussac's law of gaseous volume, how does Gay-Lussac's law of gaseous volume differ from the other four laws of chemical combination? From the other four laws of chemical combination. Answer to the last question, you will get the answer from your textbook. You can write down the point wise. Number one, temperature and pressure dependent, Gay-Lussac's law. Temperature and pressure to be mentioned. There is temperature pressure dependent. Other four laws are independent of temperature and pressure. Second bullet, Gay-Lussac's law is volume related, while other four laws are mass related. While other four laws are mass related. Third point, first four laws can be proved by Dalton's atomic theory. Can be proved by Dalton's atomic theory, while Gay-Lussac's law, being volume related, cannot be proved by Dalton's atomic theory. Now, one important problem. Write down. Very important sum indeed. two metallic oxides of a metal in contain 27.6% and 30% of oxygen by mass respectively. If the formula of the first oxide be M3O4, find that of the second oxide. Find that of the second oxide. Whenever problem will be given like this, we will follow a definite method in the table form. That is the easiest way. You can cross check, blah blah. So, is it noted down? Everyone, please.
Yes, sir.
Okay. What to do? This is called Kenny-Saros method. What I am doing? Some table form, elements, first column, weight percentage, okay, element, then atomic weight of the respective element. First element is metal. Okay, before doing this, do one thing in the easiest manner. Let the atomic weight of the metal be X. We have to find out the atomic weight of the metal first. After that, we will apply the table. Okay, for known elements, we can do the table directly, but here the atomic weight of the metal to be find out first. Let the atomic weight of the metal be X. Therefore, in first oxide, when the formula is given, apply in that case. In the first oxide, metal is equal to 27.6% is oxygen. Okay, 27.6% is oxygen. Therefore, metal is equal to 72.4%. Is it? In M3O4, formula is given. Molecular mass is equal to atomic weight of metal has been considered as X. So 3X plus 16 into 4 for oxygen becoming 3X plus 64. This is the molecular mass of M3O4. Therefore, percentage of metal is equal to 3x divided by 3x plus 64 that into 100. Is it clear? 3x part of metal is present in 3x plus 64 part of the compound. Therefore, percentage is 3x divided by total into 100. And this must be equal to 72.4%. From this, find out the value of x. Find out the value of x and tell me. Let the atomic weight of the metal be x. As per the given formula of the first oxide M3O4, atomic weight of metal is x. Therefore, molecular mass becoming 3x plus 64. of which 3x part is metal, therefore percentage of metal is 3x by the total into 100, that must be equal to 72.4. From there, find the value of x. What is the value of x?
So X will be 56. So 56.
5.976, I think so.
So after round off it is 56.
Okay, okay. It is to be considered as 56, right? It is to be considered as 56. So, of this type of problem, wherever the formula is given, unknown element, find out the atomic weight by applying this way. After getting the atomic weight, now comes to the Cannizaro's method in the table form. We are going to find out for second oxide, metal is equal to 70%, oxygen is equal to 30% given. Formula to be find out. So element, metal and oxygen, first column. Atomic weight, for metal we have calculated 56, for oxygen 60, so second column. Then atomic ratio means percentage 70%, that divided by respective atomic weight. For metal it is 70 by 56 to give you number of gram atom. 56 gram of metal is equal to 1 gram atom. So 70 by 56 will give you the atomic ratio, and this will be for oxygen, it will be 30 by 16 number of gram atom. Calculate this. Seventy by 56 is becoming 76 by 70 by 56 is equal to
So 1.25.
1.25, and 30 by 16 is equal to,
So 1.875.
fine, I have done already. Next column is least ratio. This is interesting. Least ratio means out of these two values, you make the least one as 1. So this is becoming 1, and this is becoming 1.875 divided by 1.25 is equal to 1.5. That means after getting this least ratio, you divide each by the least one. That is called the least ratio. 1.25 by 1.25 means 1, and this by 1.25 becoming 1.5. Finally, it is atomic ratio. It is atomic ratio that should be whole number for each element. You multiply this and this by the least value, so that each becoming whole number. So to be multiplied by this into 2 means 2, this into 2 means 3. So the least factor is 2, multiplying this and this by least factor 2, both becoming whole number. So the formula of the second oxide is M2O3. Formula of the second oxide is M2O3.
Sir, it is like the empirical formula.
Is it like?
The empirical formula.
Right. Right. Here, no mentioning about the empirical formula or molecular formula. So considering that, we have to consider this as a molecular formula.
Yes,
Or
sir.
the question may be simplest molecular formula. Is it okay? Okay. Now, for competitive exam, if anyone solve this type of problem like this way, that will be a very big problem, calculation, and will take a large time, for which you have to miss so many common questions. So time factor is a very important one. So what can be done for the competitive exam guideline? Again, don't apply this method for your board exam. So be careful. What to do? Make a synopsis. This is first oxide, and this is second oxide. Metal 72.4%, oxygen 27.6%. Formula M3O4. Second oxide, metal is 70%, oxygen is 30%. Formula to be find out. Okay, so for competitive exam, everyone be careful. 72.4% of metal corresponding to 3 atoms of metal, is it? Please respond. 72.4% of metal corresponding to 3 atoms of metal, is it?
Yes.
Yes, sir.
Therefore, 70% of metal will be equivalent to what number of metal atom? You follow me? If 72.4% of metal corresponding to 3 metal atoms, then what number of atoms will be, metal atom will be corresponding to 70%?
The 70 into 72.4 by 3.
Right. So, no, not that. 72.4% corresponding to 3 metal atoms. Is it? Therefore, 70% corresponding to 3 into 70 by 72.4. This is one calculation for metal.
2.9.
2.9. 2 point, second decimal. Go at least up to third decimal.
2.900.
2.9. Okay. 2.9. Next, in the same manner, for oxygen, 27.6% corresponding to 4 oxygen atom. Therefore, 30% corresponding to 4 into 30 by 27.6. Is equal to?
The 4.34.
4.347.
4.34. Is it?
Yes.
Okay. Therefore, M is to O is equal to 2.9 is to 4.34. First step is equal to among these two. This is the least one. So this ratio is 1 is to 4.34 by 2.9 is equal to 1 is to
1.5.
1.5 multiplied by the least factor is equal to, hence formula is N2O2. So different ways for different exams. Okay, to save the time. Okay, so that's all about the 5 laws. Okay, today, to make the class very interesting, I want to check yourself, your brain and capability. Just write down very interesting sums. Okay. Hydrogen has 2 natural isotopes. Hydrogen has 2 natural isotopes. Hydrogen has 2 natural isotopes, 1H1 and 1H2. While oxygen has 2 isotopes, 6 oxygen, 16 oxygen, 8 oxygen, 16, and 8 oxygen, 18. So 2 isotopes of hydrogen and 2 isotopes of oxygen. Question is, first question, which molecular mass for water with these isotopes, which molecular mass for water with these isotopes is not possible? Option is 19, 20, 24, 22. Or another format of the question, or how many different types of water molecules are possible? How many different types of water molecules are possible with these isotopes? Giving you 2 minutes time. Hurry up.
Sir, answer is C. Answer is C.
Answer is C. Your answer. Anybody please? Any other student please? Any other student please? Ashmita, Himika.
1 minute, sir.
Okay, take time. Who said the answer first? Name please.
Sir, Arya Dev.
Okay. Arya Shubhakar.
Excuse me, sir.
Arya Shubhakar.
Yes, sir.
Okay. Tell me the answer. Arya has answered option C. And I have for the second part, number of different water molecules. What is the possible number of water molecules formed by the given isotopes?
6.
Okay. So your answer is option C, 24 and 6. Let me check. Can I proceed, please? Okay. See, first one is H2O. Consider protium isotope of hydrogen and 16 isotope of oxygen. Molecular mass becoming 2 plus 16, 18. Second one, same way, protium isotope of hydrogen and 18 oxygen of isotope of oxygen. Molecular mass becoming 18 plus 2, 20. Third case, deuterium isotope of hydrogen and 16 isotope of oxygen. Molar mass becoming 2 to the 4 plus 16, 20. Fourth one is deuterium isotope of hydrogen and 18 isotope of oxygen makes 22. So 4. Okay, comes to the next one. 1 protium. So this is interesting. Anybody can do all these 4. But now comes to the interesting one. 1 protium, 1 deuterium, and oxygen 16. So 16, 17, 18, 19, molar mass becoming 90. In the same manner, 1 protium isotope, 1 deuterium isotope, and 1 18 oxygen isotope becoming 21. So answer to the first part, 19 is given, 22 is given, 20 is given, matching everyone. So 24 is not possible. Number 1. So first answer to the first answer is option C, and answer to the second part, number of different water molecules 1, 2, 3, 4, 5, 6. Be careful about these two. So answer is 100% okay, given by Arya. Okay. Next topic. Okay. Avogadro's hypothesis. Avogadro's hypothesis. Can anybody of you say who should give the honor for this law? Is it Avogadro or someone else? Any idea? Avogadro said that under similar conditions of temperature and pressure, equal volumes of all gases contain the same number of molecules. But actually, after experimental verification and failure of Berzelius, Rutherford was able to develop his hypothesis. So credit should go mainly to Berzelius, who said that under similar conditions of temperature and pressure, equal volumes of all gases contain same number of atoms. Okay, so the credit should go to Berzelius, but when hypothesis means that's just a concept, depending on so many other factors and other laws. Berzelius developed his hypothesis based on Dalton's atomic theory and Gay-Lussac's law of gaseous volume. But after having Berzelius's hypothesis, when the concept was applied in experimental overview, it was found that atoms become divisible, which goes against Dalton's atomic theory. In order to solve this problem, Avogadro just changed the concept of atom to something else. He called it as a molecule that can be divided into atoms. Okay, so I think friends should go to Bergelius. Just have there is a story. Just have a look and for your knowledge. That's all. So Avogadro's hypothesis, under similar conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. So this is known to everyone. You know, you also know that. But application part of Avogadro's hypothesis is very, very important. So you write down applications of Avogadro's law or Avogadro's hypothesis. Applications of Avogadro's hypothesis. Number one, atomicity of elementary gases. Atomicity of elementary gases. Avogadro gave the term atomicity, that is the number of atoms present in one molecule of an element or compound. So atomicity, we know most of the metals are monoatomic, inert gases are monoatomic, most of the gases are diatomic, nitrogen, oxygen, blah blah, chlorine, bromine. Ozone is triatomic, phosphorus is tetraatomic, red phosphorus is tetraatomic, P4, and the highest is the sulfur, S8, octatomic. Okay, so concept of atomicity. Number two, that the concept of a vapor density, the concept of a vapor density, and the relation between molar mass and vapor density, and the relation between molar mass and vapor density.
Sir,
Yes.
sir, why was my answer of 24 wrong?
Sir,
That last question you had asked, sir, why was my answer wrong? 24.
your answer is correct.
Oh no, you had placed a
No,
cross mark.
no. C means the question was which is not possible.
Yeah. Okay, sir, got it.
Is it okay? Your answer is
Yes.
100% correct. I
Yes,
told
yes,
that
sir.
24
Sir, I
is not
misunderstood.
correct. Not correct means the molar mass of water may not be 24 in any way.
Yeah, got it.
Is it? Follow the question.
Yes, sir.
Is it clear?
Yes.
Okay, thank you. Now, so the definition of vapor density and the relation between vapor density and molecular mass. Next is molar volume of gases at NTP is constant. Next one is mole concept and Avogadro's number. Mole concept and Avogadro's number. Now, one by one comes to the first one. I told you already what is called the atomicity. It is the number of atoms present per molecule. It may be elementary, it may be compound molecule. Elementary molecule ozone, O3 is triatomic. Compound molecule CH4 is pentatomic, and so on. Next is determination, the vapor density and the relation between molar mass and vapor density. Write it down. Vapor density of a gas, vapor density of a gas is defined as the ratio between the mass of certain volume of gas, ratio between the mass of certain volume of a gas to the mass of to the mass of same volume of hydrogen, under similar conditions of temperature and pressure. Under similar conditions of temperature and pressure. Thus, vapor density is denoted by capital D, while the normal density is denoted by small d. I am not talking about small d, it is vapor density. Thus, vapor density D is equal to, we can say that, mass of, in a general manner, okay, mass of V ml of gas by mass of V ml of hydrogen gas. Only the thing you have to mention, at same temperature and pressure. This is mandatory. Same temperature and pressure. Must have to mention. Okay. Now, as per Avogadro's hypothesis, under similar condition of temperature and pressure, same volume of all gases contain the same number of molecules. Same volume of all gases contain the same number of molecules. If we consider that under the given temperature and pressure, the ml of the gas occupy n number of molecules, so mass of n molecules of gas divided by definitely the same volume, same number, mass of n molecules of H2 gas. Cancelling n. Next step, mass of one molecule of the gas by mass of one molecule of hydrogen gas is equal to half mass of one molecule of the gas by mass of one atom. Since hydrogen is diatomic, so half taken common at the beginning, mass of one atom of H2. So what is this? Mass of one molecule of a gas by mass of one atom of hydrogen. What is this? What is called? This is called the molar mass or molecular mass. Mass of one molecule, always in terms of one atom of hydrogen. Mass of one atom of element by mass of one atom of hydrogen, giving atomic mass, and mass of one molecule of the gas by mass of one atom of hydrogen, giving molecular mass, is equal to half into n, where n is the molar mass of the gas. Molar mass of the gas. Molar mass of the gas. Therefore, B is equal to n by 2, or n is equal to twice B. This is the relation between molar mass of a gas versus its vapor density. Okay. Now we will do some modification on carbon 12 scale, considering carbon 112 is the mass of carbon 12 isotope. Atomic mass of hydrogen has found to be 1.008. Here it was considered as 1. Considering the mass of considering the exact atomic mass of hydrogen as 1.008, 1.008, the modified relation is n is equal to 2 into 1.008 makes 2.016d. So this is more accurate. Must have to remember 2.016d. 2.016d. Now, what is the relation between normal density versus vapor density? What is the relation between normal density and vapor density? Write down. Normal density means mass per unit volume. Say gram per ml or gram per liter. While D being ratio of two normal densities having no units, unitless. Another thing, as we have mentioned, D is equal to vapor density. D is equal to, we have mentioned mass of V volume. Instead of that, if we say mass of 1 liter of gas at NTP by mass of 1 liter of hydrogen gas at NTP. This is mass of 1 liter of the gas means D normal, small d means normal density, D of gas by D of hydrogen. Mass of 1 liter of gas in grams per liter called the normal density. So normal density of gas denoted by small d divided by normal density of hydrogen. This is the relation between vapor density and normal density. This value is 0.09. Normal density of hydrogen is 0.09 gram per ml, gram per liter. 0.09 gram per liter. Therefore, normal density of any gas is equal to vapor density of gas into 0.09. So this is another relation, direct relation for doing numericals. So normal density of a gas is equal to the vapor density of the gas into normal density of hydrogen, the value of which is 0.09 or 0.089, whatever you like. Okay, so today's class is up to this. Next day, I will do the other application part of Avogadro's hypothesis. In between, you just go through the first 4 laws in details, then follow the explanation and the worked out numericals. Try to solve the exercise problems, failing which just ask me in the next class so that I can solve each and every one. This is first part. Second part, about the applications of Avogadro's hypothesis. Just have a look. I will do the proof from, molar volume at NTP for all gases is constant, that is 22.4 liter. Then the other calculations, and particularly most important is the concept of mole. Most of the student fails to convert one part to the other in doing the numericals, and they generally do a broad answer that goes wrong for the competitive exam, because you may get the correct answer, but it will take a huge lot of time. In competitive exam, your target should be follow the easiest way following your conception so that minimum calculation can be done to save the time so that you can answer most of the questions. Okay, so that's all about today's class. Now I'm handovering it to
Sir,
our
sir,
huh?
sir, which book to follow?
Okay, you are from which board?
Sir, I say, sir, now I am in PU board, pre-university board.
Okay, but in 11, 12, which board you are going to take the admission?
Sir, that is a different board, state board, sir, PU board.
Okay, all over India for all national entrance exam, competitive exam, syllabus is more or less the same. Okay, the only difference is some chapters are there in class 11 for ISC, while the same chapters are included for board, West Bengal board or any other board, along with CBSE in class 12. So there is no variation in any chapter. Only the fluctuation is where some are there in class 11 and the same are there in class 12. So only that difference. So in that case, I prefer to follow comprehensive. Okay, or Nutan or Srivastava or Dinesh.
Okay, sir.
You will get our study material and everything. Okay, along with that, you definitely follow some good textbook. And for West Bengal board students, ISC, along with CBSE, you can also follow ABC of chemistry. ABC, modern publisher, ABC of chemistry, comprehensive for ISC, Kalyani publication, KL Chug, and Dinesh. These are the very, very good one. Brotin sir, are you there?
Yes, sir, I'm here.
Okay, today's class is over.
Okay.
Okay,
So,
you can conclude now.
sure. Thank you, sir.
Okay.
So students, I think you had a great session with sir. Again, just to reiterate, if you have any questions, any queries, please reach out to us. You have our contact details. Reach out to us by email, over phone call, or through WhatsApp, and we are more than happy to respond to any queries you may have. And we'll again have the next class next Saturday, same time, from 3 to 5 p.m. All right. Any questions from anyone? If not, thank you very much. Stay safe, stay healthy. Take care. Thank you. Bye-bye.
Okay, bye.